All right, we're going to go ahead and get started with our third lesson in our surface area unit. Don't forget to put your page numbers down. I'm on page 136. I think I forgot to include that in yesterday's video. Also the date. Today's date is the 10th of April, 2019. Please leave space for your cues and summary. So the attached picture should have these exact notes for you. Basically, we're talking about the difference between triangular prisms and rectangular prisms. So make sure you fill in those blanks. Basically, the difference between these two shapes, obviously we can see that one is a rectangle, the other is a triangle. Now, when we find the area of those two, they're similar until the last step. So in finding the area for a rectangle, we know that we find the area by multiplying the base times the height. And with triangles, we also do base times height, but then we divide it by 2. So make sure that when you're finding the area of these two shapes that they're using the right equations. And again, this question asks, describe what is different about the two shapes and their areas. Well, basically, one is a rectangle, one is a triangle, and the difference in their equations is that with a triangle, we multiply base times height and then divide by 2. This is going to come into play when we find the surface area because we're finding the area of both rectangles and triangles. Down below, it just asks us to shade the bases. Remember the bases, we determine what the base is from the two parts of the prism that are parallel to each other and are congruent. So remember, congruent means the same. So you can see here that the two bases that I highlighted in orange, they are congruent, meaning they are the same shape with the same measurements, and they are parallel to each other. So you can see that I shaded that in for each of the 3D figures and the net. Question number 1 is asking us to decompose this net into different congruent figures, then find the area of each figure. So you can see here that I labeled, let's go ahead and fix that. You can see here that I labeled the rectangles as shape number 1 and the triangles as shape number 2. So I'll go ahead and highlight that. Here we have our rectangles, we're calling shape 1. And then our triangle is going to be our shape number 2. Again, finding the total surface area is finding the area of all the faces. So basically I find the area of all 5 of these faces and add them all together. So with shape 1, that's a rectangle, so we multiply length times width. My dimensions are here. I multiply and get the area of 51 inches. So what that means is that one of those faces is 51 inches. And if we were in class right now, I would ask you, how many of those shapes do we have? And you would say 3. So here we have 51 square inches, 51 square inches, and 51 square inches. Notice we also have shape number 2, which is a triangle, so we use base times height divided by 2. My base is 6. Be careful. We don't have the 6 written out, but I know that if I have this length as 6, because these are congruent rectangles, means they're the same dimensions, this would be 6, and this would also be 6. If this is 6, it's a rectangle, so this would be 6. So my dimensions would be base times height, or 6 times 4. Because it's a triangle, I then divide by 2. So 6 times 4 is 24. Divided by 2 is 12. Okay, and again, I don't just have one of those triangles, I have 2 of them. So in finding the total surface area, I take the area of all the faces. So I have 1, 2, 3 rectangles of 51 square inches. So 51 plus 51 plus 51. And then I have the 2 areas of the triangles, which were 12. So we have plus 12 plus 12. If I add 51 plus 51 plus 51 plus 12 plus 12, I get 177 square inches. So again, to find the surface area, we take the area of all the faces and add them together. Let's move on to page number 2. Number 2, in yesterday's lesson, I didn't have you complete a problem on the lateral surface area. So I am going to have you do that for tonight's homework. Remember that the lateral surface area, oops, I guess I should add in the word lateral. So the lateral surface area is basically the surface area without the two bases. So again, it's really important to be able to identify what the bases are, because for the lateral surface area, you don't want to include the bases. So here, I know my bases are this triangle, which I'll just do a rough sketch, because these two are parallel and they are congruent. So those are my bases, which I'm going to not include because I'm finding the lateral surface area. So if it helps you, you can highlight those bases, fill them in. Remember, you're finding the lateral surface area, so use the dimensions to find the area of the remaining faces. I am going to do a question with you. I'm going to do question number 4. Since that one doesn't have a visual, we'll go ahead and do that one together. Number 4 reads, a carpenter is building a unique jewelry box in the shape of a right triangular prism. The base has measurements of 4 inches, 3 inches, and 5 inches. How much wood will it take to complete the project if it is 6 inches tall? So when it asks me how much wood would it take to complete the project if it is 6 inches tall, I know that I'm finding surface area for a couple of reasons. One, it says total surface area. That's what I'm finding. I also know that a jewelry box is empty, right? It's empty because we put jewelry inside of it. So if we have an empty jewelry box, I'm finding the surface area. So let's go ahead and draw a picture to help give us a visual. When I read over it again, a carpenter is building a unique jewelry box in the shape of a right triangular prism. So if I think about right triangles, that means that the triangle must have a 90-degree angle. So I'm going to roughly sketch my first base. And I'm going to include that little box there showing that it's a right triangle. And then I'm going to draw another one off to the side. We're going to say those are congruent. And then to show that they are a prism, I'm going to connect these pieces, which can be kind of hard. Okay, maybe not the best picture, but it is a prism. We have our 2 bases and we have our other 3 faces. So let's go ahead and label what these dimensions would be. Okay, the short side is going to be my 3 inches. My longest side is going to be the 5 inches. The diagonal one in the diagonal side in a right triangle is the longest. It's called the hypotenuse. It's 5 inches, and then the base will be 4 inches. We also know that the height of this project is 6 inches tall. So what that's referring to is this dimension right here. That's going to be considered the height. So we'll want to mark that green line, that's our height, as 6 inches. So there's a couple different ways I could solve this. I could solve this by creating a net. That would help me see which shape has which dimensions, and then I would add them all together. Or I could leave it like this. This is kind of a trickier way to be able to calculate the surface area, so I'm going to create a net out of this 3D jewelry box. So I know that this jewelry box is connected by 1, 2, 3 rectangles because a triangle has 3 sides. So I'm first going to draw those 3 rectangles. Doesn't have to be perfect. And then I'm going to draw the right triangles that come off of them. So there's a right triangle. And there's a right triangle. If I were to fold these all together, we would get a prism similar to this. It's actually a little backwards, but that's okay. So again, I'm going to first calculate the areas of each of these shapes, and then I'm going to add them all together. I'm going to highlight the bases in orange. We're going to call that shape 1, and the rectangles, we're going to call that shape 2, and we'll highlight those in green. So shape 1, again, is my triangle. We find the area of a triangle by multiplying the base times the height, then dividing by 2. So I need to go back and look at what my measurements are. So the base of this right triangle is 4 inches. We have 4 inches, the height is 3. Do we care about this hypotenuse? Hopefully you're saying no right now, because when we find the area of a triangle, all we need is the base and the height. Remember, the height is what's straight up and down. So if I find the area of this triangle, I'd multiply the base times the height, 3 times 4, then divide by 2. 3 times 4 is 12. 12 divided by 2 equals 6. So the area of this triangle is 6 square inches. And if the area of this triangle is 6 square inches, then the area of this triangle is also 6 square inches. So there we have shape number 1. Shape number 2 is a rectangle. We find the area of a rectangle by multiplying the length times the width, or you could also say base times height. Now, the length of this rectangle, if we look over here, we see that it's 6 inches. So this length right here is 6 inches. Now I also need the width. If I know that this is 4 inches, then I know that this is 4 inches, and I know that this is 4 inches. So I have a length of 6 inches and a width of 4 inches, and we find the area by multiplying length times width. So 6 times 4 is 24. So I have 24, and I have 3 of those. So each of these is 24 square inches. To find the total surface area, I'm going to add them all together. So shape 1 is my triangle. I had 6 square inches plus 6 square inches. And then my shape 2, I had 3 rectangles. Each of them were 24. So plus 24, plus 24, plus 24. I don't have a calculator in front of me, so we will actually work it out. So 6 plus 6 is 12. 24 plus 24 is 48. So if I want to line all 3 of these up, 8 plus 4 is 12, plus another 2 is 14. Carry the 1, 5, 6, 7, 8. So I get a total of 84 square inches. That would be my total surface area. So again, always go back to the question. Oops, there's my work. Always go back to the question, how much wood will it take to complete the project if it is 6 inches tall? I would need a total of 84 square inches of wood to complete my project. And I'll go ahead and highlight that so I can see exactly where my answer is. Hopefully this helps explain how to complete these types of problems. You'll do the other 2 on your own. Good luck. We'll talk about it in class. And that's it.